Welcome to Edifu. In this video, I'm going to explain how we can conduct a two-sample chi-square test and how to write the result in APA format. Chi-square test is one of the very popular non-parametric tests in research statistics. It is an inevitable part of many research process. Before you watching this video, please watch my previous video on one-sample chi-square test. I have already given the link of that video in the description section below. Because in that video, I have elaborated the assumptions, requirements, and procedures of the chi-square test. Beyond that, I have also discussed some of the inevitable statistical terms that researchers are frequently using. So, I'm not going to elaborate these topics that much in this video further. I'm sure it will be perfect if you watch this video of two-sample chi-square test after watching the video about the one-sample chi-square test. Now, come to our two-sample chi-square test. For the demonstration of two-sample chi-square test, here I am with an example of brand preference study, the same example that I have had with the last video. In this example, I'm explaining the brand preference towards smartphone brands. Here is the example. When we purchase a mobile phone, we have a brand preference. This brand preference will depend on many factors. There are many smartphone brands available in the world today, but the interest of people with all brands of mobile phone is not the same. We want to test whether there is any association between gender and smartphone brand preferences. In the one-sample chi-square test, we considered an analysis of association between categories or levels under one sample, that was brand preference. But here in this example, we are going to analyze the association between two variables, that is gender and smartphone brand preference. For this purpose, I have already selected 4 leading smartphone brands. They are Apple, Samsung, Sony, and OnePlus. Now, we need respondents. For this purpose, we need to choose a perfect sample for data collection. In this example, I am going to fix 300 as our sample size. That means we are going to collect data from 300 respondents. Two-sample chi-square test is most commonly used to evaluate tests of independence. What is this test of independence? The test of independence means to test whether there is any relationship or association between the two variables under study by comparing with the distribution of data. Here, the two variables are gender and smartphone brands. The preference of male and female towards the smartphone brand may be different or the same. If there is a difference exists, then whether that difference is statistically significant or not, whether they are dependent or independent, that is our research problem. So, finding out the significant difference between two qualitative variables using chi-square test. If statistically any significant association or relationship exists, then the variables are dependent, otherwise the variables are independent. Here, the two variables that we are going to consider are gender and mobile phone brands. For conducting two-sample chi-square test, the sample size should be sufficiently large. That's why here in this example, we are going to consider our sample size as 300. Instead of percentage of frequencies, we are here going to consider the actual frequency of the data. Naturally, we have already discussed in the previous example, chi-square test is used to test the null hypothesis. Now, we move to our questionnaire. Here in this questionnaire, we have 2 questions. The first one is gender. This question represents our first variable gender. The second question is smartphone brand preference. This is our second variable for the two-sample chi-square test. For two-sample chi-square test, we need two variables. Now, how we can set the hypothesis for our research question? We need to set the null hypothesis and alternative hypothesis for our research problem. This is our null hypothesis, that is HO. There is no association between gender and smartphone brand preferences. That means the two variables, that is gender and smartphone brand preference, are independent. That means there is no relationship between gender and smartphone preference, and they are independent of each other. Now, our alternative hypothesis. That should be just opposite of that of null hypothesis. Here, HA, that is alternative hypothesis, is there is an association or relation between gender and smartphone brand preference. That means the two variables, that is gender and smartphone brand preference, are dependent. That is, there is an association or relation between gender and smartphone brand preference. So we can say they are dependent. So after we are conducting the chi-square test, if null hypothesis is accepted, then we can say there is no association. If we reject the null hypothesis, we can say there is an association or relation between gender and smartphone brand preference. These two hypotheses explain the test of independence. That means if we fail to reject the null hypothesis, we can say there is no association between two variables. That means the variables are independent. If we reject the null hypothesis, we can say there is an association between two variables. That means the variables are dependent each other. Now the research question or problem is ready. On that basis, we have formulated the null and alternative hypothesis. To collect data, we have already prepared the questionnaire and already fixed the sample size. Now, our next step is to collect the data from the target population. That means the sample that we have collected. After collecting the data, we move to our next step, that is tabulation and calculation of chi-square value. In this demonstration, we are going to use Microsoft Excel as our tool. So we are going to open the Microsoft Excel for recording the data and tabulating it. So let us open the Microsoft Excel. Create an Excel file. In this file, we are going to record the data that we are collected through our questionnaire. Our questionnaire includes two questions. The first question represents our first variable, that is gender. The second question is our brand, that is our second variable. Instead of that, we are going to add one more column in this Excel file. That column represents the respondent ID, the numbers representing the respondents. Now we are going to enter the data in three columns. The first column is respondent ID. The second column is first variable gender. The third column is our third variable, that is mobile phone brand. The first column, we need to add 1 to 300 because our sample size is 300. Each number represents one respondent. So 1 to 300, yes. The second column is the gender. Instead of entering male and female, we are just representing these true numbers. That means 1 represents male and 2 represents female, assigning numerals to our data. So instead of entering male and female, we are going to enter 1, 2 like this. Okay. Our third column is brand. We have 4 categories. So 1, 2, 3, 4. Yes. The first number represents Apple. The second represents Samsung. Third, Sony, fourth, OnePlus. Yes, instead of entering the full name of the brand in the third column, we are going to enter the corresponding numbers. 1, 3, 2, 4, 2, 3, 2, 1, like this. This way, we need to enter all the 300 rows. So, we need to enter responses of all the 300 respondents. So, please enter 300 rows. Be fast. Now the data is ready for processing. The data of all the 300 respondents has already been recorded here. Now I am going to delete these two columns. Okay. The next step is to create a contingency table. Actually, this contingency table is a cross tab. A contingency table is a table which shows the relationship between two categorical variables. Here the two categorical variables are gender and the mobile phone preference or the brand. We need to identify the relationship between the male towards the 4 mobile phone brands, then female towards the 4 mobile phone brands. How many male prefer to Samsung? How many male prefer to Apple? How many male prefer to Sony, like this? So we need to calculate that. That table is called a cross tab or contingency table. Normally in ChiSquare test, it is known as contingency table. So it is a two-dimensional table. The row represents the gender and the column represents the brand. So in Excel, we can create this contingency table using a technique called pivot table. So now we are going to create the pivot table. So for this purpose, just go to Insert menu, then click on Pivot Table. You can see a window there. Click that icon. Now you can see a Create Pivot Table pop-up window. Here you need to enter the range of data. That is input range. You need to enter the entire area that we have recorded the two variables. Here is the input range. Now click on OK. Now you can see the pivot table. I have already discussed that the row and column. The row represents the gender, then column represents the brand. So drag the brand to column and gender to row. Now we need to get the number of brand preferred by each gender, they're male and female. So we need to drag that brand to the value column near to the row. So drag that. Yes, now you can see the quantity. This is not the quantity, it is the sum of the values. So we need to change to count. Here you can click the small arrow, select value field and select the count. Then click OK. Yes, now it's right. We can see the detailed cross tab or detailed contingency table here. Now we are going to copy this table and create a new sheet. Paste it here. Paste the value, not the equation. We need the value. Yes. Now we need to format it properly. Replace the 1 with male and 2 with female. Delete this column. And change the brands, 1 with Apple, then 2 Samsung, 3 OnePlus, then total. The last row is total. Then just format this column. This is the observed frequency, or we can say actual frequency. So change the table into a presentable format, change your background. Now it should look good. Now you can see here, the row represents the gender, 2 rows, male and female, and the column represents our mobile phone brands. 4 brands are there. So now look, here 23 is the number, represents the male preferred to Apple. That is 23 male preferred to Apple, 54 male preferred to Samsung, 43 male preferred to Sony, and 32 male preferred to OnePlus. The total number of male you can see in the last column, that is 152. The next row is female like this, 54 female like Apple, then 45 Samsung, 23 Sony, and 26 OnePlus. The total female number is 148. So total 152 plus 148, 300. That is our total sample size. Now in the last row you can see the total of each brands. That is 77 people prefer to Apple, both male and female. The total 23 plus 54. 99 people prefer to Samsung, 66 people prefer to Sony, and 58 people prefer to OnePlus. So total is 300. Now this is called the contingency table. The next step is to create the expected frequency. The same way that we are creating the one sample chi-square test. But here we are going to calculate the expected frequency in a different way. So next table is the expected frequency. Expected frequency. Then copy this observed frequency table, paste it below. Now you need to paste it in the format way, the same format, not the values. Now delete all the numbers. We are going to calculate the expected frequency. Here, the expected frequency should be calculated using an equation. That is, for example, the observed frequency of male towards Apple is 23. We need to calculate the expected frequency of the same data. For calculating that, equation is this: the total of row divided by the total of column into grand total. That means here, the total of male is 152 into the total of Apple 77 divided by the grand total. That is our sample size, 300. Now we are going to apply this equation here. Equal, start a bracket, G4, that is a column, represents the total of male, that is 152. Then into C6. C6 is the total of Apple, 77. Then divided by 300. Press enter. This is the expected frequency of male towards Apple. You can see 23 is the observed and 39.01 is the expected. This way you need to find expected values of remaining columns. 152 into 99 divided by 300. That is 50.16. So this way you need to find out all the remaining columns, but it is very tedious. We can ease this process by making some modifications in the first equation. Here you see the first row representing male, the 152 and 300 is constant. Only value changing the equation is the column sum. For example, the first male Apple expected value is 152 into 77 divided by 300. The next column again 152 into 99 divided by 300. In all the rows, the 152 and 300 make constant. So change that cell and freeze it. Here, modify it. Now 152 is G4. Freeze it by pressing F4. That 152. That's not going to be changed for all the 4 columns. Freeze it. Then the 300. That is a column, last one. Yes, this one. Freeze it. F4. That is G6. Now it's okay. Now you can drag to remaining columns. Now you get the all values. Now it is very easy to do this. The same way you just do for female. That is 148 into 77 divided by 300. Freeze the first and last argument of the function. Yes, freeze it. F4, enter key, then drag it down. Now it is okay. Now we have all the expected values. Now reduce the decimal place to 2. Then total it. The row total. Now it is total is equal to observed. Total the column 77, the same as above. Then drag it down. Now drag it. Now all the totals are same, expected and observed. Now the observed frequency and expected frequency are ready. Now we need to solve it through the chi-square test equation. Here is the chi-square test equation. Here is the equation. O minus E divided by E. O means observed, E means expected. Again, divided by E means expected. In one sample chi-square test video, we have already discussed about this equation. The same equation we can apply in two sample chi-square test. Now, first we need to allot the column for observed, then expected, then O minus E, observed minus expected. Now O minus E whole square difference of observed and expected. Now observed minus expected whole square divided by E. Yes, the columns are ready. Now we need to copy the observed and expected data to the new table. Now copy the first row. It is in horizontal form. Copy it. Now we need to convert into vertical form. So right button, you just select paste special. Here it is. Then select values. Then transform. Select this option. Okay. Now the horizontal data convert into vertical. Then copy the second row. The same way apply it here. Right button. Paste special. Value transpose. Now it is okay. Now the observed values are there. Same way, just copy the expected values. Paste special. Value transpose. Second row. Copy. So okay. Reduce the decimal place to 2. Now the observed and expected data are ready. Now calculate O minus E. That is 23 minus 39.01. Apply the equation. Press enter. Drag it down. Now the O minus E is ready. Next, square the difference. Equal K4. The power symbol. You can set symbol in the combination key of 6 in the top row of keyboard. Then 2. Now it's ready. Then drag it down. Reduce the decimal places to 2. Okay. Now we need to divide the O minus E whole square by the expected value. That is equal to L4 divided by J4. Drag it down. Reduce the decimal place. Now total that last column. That is our chi-square value. Total it. That is the sigma, K sigma I. Total all the results. Chi-square value. Total autosum. You can get it. 19.93. That is our chi-square value. 19.93. Now chi-square value is ready. Our next step is to test the hypothesis. For testing the hypothesis, we need 4 more data. They are level of significance. We have already discussed this level of significance in the previous video of one sample chi-square test. Second is degree of freedom. The third one is chi-square critical value. And we need the p-value. So 4 data we need to test the hypothesis: level of significance, degree of freedom, chi-square critical value, and p-value. So allowed 4 columns for that. Now it's ready. So level of significance normally 0.05. The commonly used level of significance 0.05. The next step is to find the degree of freedom. In one sample chi-square test, the degree of freedom is k minus 1. The number of categories minus 1. In one sample chi-square test, we have only one sample or one categorical variable. So there we have 4 brands. So 4 minus 1. 3 is the degree of freedom. Here, the calculation is slightly different because here we have 2 categories. So equation is row minus 1 into column minus 1. Here row, 2 elements are in the row, male and female. So 2 minus 1 into column minus 1. In column represents the brands. 4 brands are there. So 4 minus 1. So 2 minus 1 into 4 minus 1. That is 1 into 3 equal to 3. So 3 is the degree of freedom. Now we want to calculate the critical value. In 2 ways you can calculate the critical value. First, refer the chi-square distribution table. Here is the chi-square distribution table. We can see the degree of freedom in the first column. On the top row you can see the level of significance. So our degree of freedom is 3. Take that value and select the value which met with 0.05 from top row, 7.81. You see, 3 degree of freedom, 0.05 as a level of significance. So 7.81 is considered as our chi-square critical value. 7.81. Now we can calculate the same value using Excel function. So delete this table. So this is an Excel function for calculating critical value. That is ChiSquare.inv.rt. The first argument is probability, that is level of significance 0.05, comma, the degree of freedom, that is 3. That's it. Close the bracket, press enter. You see the same value, 7.81. So if you are using Excel, you can apply this equation instead of referring the chi-square distribution table. 7.81 is our critical value. Now the next we need to find the p-value. P-value means probability value. For finding that probability value, there is an equation in Excel. That equation is equal ChiSQ.test. So 2 arguments are there, actual range and expected range. Here you don't select the expected range from the table that we are created for calculating chi-square value, but from the contingency table. So select the actual range from the contingency table. Here it is. Now select the expected range from the contingency table. Close the bracket. Then press enter. This is our p-value, 0.00018. Now level of significance are ready, degree of freedom, critical value and p-value. Now we can find out the chi-square value using the p-value. If you know the p-value, you can directly calculate the chi-square value. Equation is ChiSQ.inv.rt, the same equation that we are applied for calculating critical value, but the probability value here it is p-value. That's the only change. The first argument of probability should be the p-value, and second is normally the degree of freedom. Close the bracket. You see the same value, 19.93, same value. Now all the values are ready. Level of significance, degree of freedom, critical value, p-value and chi-square value. Now we move to test the hypothesis. There are 2 methods we can test the hypothesis. The first one is using critical value approach. The second one is the p-value approach. In research thesis and research purpose, normally p-value approach is used, but for academic project purpose, we can use the critical value method. Now we can first check how we can test the hypothesis using critical value method. In critical value approach, we are comparing test statistic with critical value. Test statistic means the chi-square value. Critical value, that we are already find it out using the equation as well as the chi-square distribution table. To understand this, this is a chi-square distribution. The speciality of chi-square distribution is that the pattern of distribution is changing according to the degree of freedom. If the degree of freedom is changing, naturally the pattern of distribution also changing in chi-square distribution. The critical value is the value that divides the chi-square distribution into two parts. That is the importance of critical value. So here the critical value is 7.81. Then we can record that critical value in the chi-square distribution table. Here it is 7.81, suppose. Now this point divide the whole chart into two parts, the left side and right side. Left side of critical value and right side of critical value. The left side of critical value is acceptance region, the right side is rejection region. If the test statistic value is left side, we are not reject the null hypothesis. If the test statistic value is right side of the critical value, we are going to reject the null hypothesis. Now you see, second is our test statistic or chi-square value, that is 19.93. Definitely this 19.93 is greater than 7.81, or it resides right side of the critical value, that is here 19.93. Now we can conclude that our null hypothesis is rejected, because the rule is that if we compare these two values, critical value and chi-square value is greater than critical value, we can say we are rejecting the null hypothesis. If the chi-square value is less than critical value, we are not reject the null hypothesis or fail to reject the null hypothesis. Here we are reject the null hypothesis. That means there is a strong association between gender and smartphone brand preference. Now the second option, that is a p-value method, p-value approach. In p-value approach, we are comparing the p-value and level of significance. We can say alpha. So the p-value and level of significance. Here is the first rule. If the p-value less than or equal to alpha, then you can reject the null hypothesis. P-value greater than alpha, then we fails to reject the null hypothesis. This is a golden rule of p-value approach. Now we can check whether our p-value is greater or less compared to level of significance. Here p-value is 0.00018, alpha is 0.05, and p-value here is less than alpha. So we reject the null hypothesis because our p-value is less than our level of significance. We can reject the null hypothesis. That means it has a statistically strong evidence that there is an association between gender and brand preference. Now we can check how we can report this result in our project or research paper. Reporting and interpretation for project, that is on the basis of critical value approach. First, you have to depict the observed frequency as well as expected frequency tables. This is a must. The table that we have created in the Excel, copy and paste it into your project. Now we can interpret the result. Here is the interpretation. Since the calculated chi-square value of 19.93 is greater than the critical chi-square value of 7.81, there is a strong evidence to reject the null hypothesis. Therefore, it is inferred that there is a significant association between the gender and smartphone preference. This is our interpretation. We can do this in your projects. Now, how we can report in research papers? It should be in APA format. APA stands for American Psychological Association. Now we can check how we can report it in APA format. Here, first of all, you have to depict this table just like this. Chi-square test, association with smartphone brand. The first column, gender. Second column, 19.93. That is our chi-square value or statistical value. Third column is our p-value. Now, this is the interpretation in APA format. A test of independence was calculated comparing the gender with the smartphone brand preference. Chi-square within bracket 3, that is the degree of freedom, comma, n equal to 300, that is our sample size, close bracket equal to 19.93, that is our test statistic, that is a chi-square value, semicolon, p less than 0.05. So here there is a statistically significant association between gender and a smartphone preference. This way you can write the interpretation in your research paper. So we have concluded the topic. I hope you enjoy this video, you like this video. If it is helpful for you, I am very happy. So don't forget to subscribe my channel and press that bell icon for future updates. Thank you. See you again.